Hello, I'm Maria Garcia Camprubí. I am the project coordinator of the DIGIT project and I work at Itainova. Itainova is a non-profit public technological center. It is located in Zaragoza in the north of Spain. The goal of the DIGIT project is to build an industrial IoT platform for the mining industry. The concept is very simple. It consists of gathering data, sending this data to a platform where we will integrate different kind of models and AI algorithms to post-process this data, and then all the data, the raw data and also the output from the model will be displayed in a decision support system that will be available for the miners, the end users, who will be able to check the predictions that we hope will help them to manage the mining operations. With the DIGIT platform, we aim at improving the safety in the mining operations and also to minimize the impact of the mining operations on the environment. At the same time, we will work on the energy efficiency in order to and the operations efficiency in order to improve the benefits of the companies. The TRL of the DIGIT platform is around TRL 5 or TRL 6. So by the end of the project, our aim is to demonstrate that this technology can help the mining industry. However, it is still a way to go until the commercialization or the market uptake, and this is our future work. The DIGIT consortium consists of 16 partners from 9 different countries. Itainova from Spain, Core Innovation from Greece, Brunel University London from the United Kingdom, Tampere University from Finland, Pro Technology from Italy, Institute of Communications and Computer Systems from Greece, Subterra Ingeniería, now Sistra, from Spain, Stratagem Energy from Cyprus, Eurocore Consulting from Belgium, Libra from the United Kingdom, Marini Marmi from Italy, Tapo Jarvi from Finland, Sintef Norlab, now Nemco Norlab, and its linked third party Sintef Helgeland from Norway, Titania from Norway, Schneider Electric from Italy, IoT from Germany. Now IoT has been replaced by Centrix Lab in Serbia. Regarding the data gathering, we will gather data from people. We also will gather data from the assets and also from the environment. In the environment, we will take care of water quality, air quality, and also geotechnical stability. In the platform, we are developing different kind of models like digital twins for the fluid dynamics processes, also for the geotechnics, and also AI models for predictive maintenance, for optimization of the mining operations, and in the decision support system, we will have all the dashboards showing all the results.
The methodology that we have developed in Itainova is pretty interesting and pretty useful, not only for underground constructions like mines, but also for buildings. In this case, we are working also in different projects where we are working on the assessment of the ventilation inside buildings like hospitals or residential buildings. The methodology that we have developed, coupling the CFD simulations and the reduced order modeling, allows the end user to see how the ventilation works inside different scenarios. With this main idea, the end user is able to see how the ventilation and the distribution of the air in a closed space can be affected by different parameters as the ventilation ducts or the temperature. This coupled methodology of CFD modeling and reduced order modeling allows us not only to assess the ventilation inside buildings, but also to save energy. In Itainova, we have developed a methodology that couples the computational fluid dynamics simulations with the reduced order modeling. This methodology allows the end user to give a fast response according to different input parameters in the CFD model. Usually, computational fluid dynamics simulations are very time-consuming, so in this case, we are saving this time by building a reduced order model.
I'm Guillermo Vaquero. I'm a mining engineer working in the Research and Development Department of Sistra Subterra, and I'm in charge of the technical management of Digit project. Within the Digit project, we are developing two different technologies there. Brunel's team is in charge of the big data analysis, and we, as Sistra Subterra, are developing the geotechnical digital twin, which is going to be focused on the tailing storage facility. The main idea of the Digit project is to harmonize very different technologies, not only related with mining field, but with only very important fields that are arising those days, like artificial intelligence or big data optimization. With the development of the smart garment, we are going to be able to measure all the parameters for the workers working in the mine, not only on the open pit, but in the underground areas, which are critical for increase and enhance his safety. With the predictive operation and predictive maintenance, we are going to be able to save money to the companies, as we are going to be able to predict how we can prevent the failure of one machine or different machines, etc. With the smart scheduling framework, we are going to be able to develop better predictions for operation, but also very important data for end users, which are the production data. All these technologies are going to be integrated in a decision support system, which is going to be a final dashboard, which will allow the end user to check in a very simple way how all these technologies described before are working in the mine in a very fast and very optimal way. Sistra Subterra is in charge of La Parrilla, which is a mine located at the central part of the Iberian Massif, located at the southwestern part of the Iberian Peninsula. There we are developing several works, mostly focused on the tailing storage facility of the mine. In the tailing storage facility, we have installed 3 different sensors, which are located in pairs. Let's say we have 3 different boreholes, and each borehole contains 1 piezometer and 1 earth pressure cell. These sensors are going to serve us to connect our digital twin to give it a sense of real digital twin, which is going to be a geotechnical model giving us results in true real time. In order to properly develop these 2 technologies mentioned, we are receiving real-time data in a daily period. We are analyzing this data periodically, and we are integrating it into our digital twins. Brunel's team is analyzing this data to give it a big data analysis, so it can help us and we can correlate our geotechnical digital twin with the results of the outputs of the big data analysis. With the implementation of these 2 technologies, we are going to be able to increase the safety of a critical mining facility, which is a tailing dam facility. So this is going to help the mine to decide when and why the mine is going to fail. Maybe the dam is going to get broken because of the tailing disposal or any drainage failure. We are going to develop 3 kinds of different digital twin models. The first one is going to be focused on the digital twins of assets, which are going to allow us to analyze how the machinery and all the machinery underground and also on open pit are functioning, giving us real-time data. With the geotechnical digital twins, we are going to be able to analyze for example, how pore pressure of groundwater is going to end into a failure of the slope in the open pit, but also in a critical structure like a tailing dam area. With the fluid dynamics digital twins, we are going to be able to develop and simulate how gases are moving within the underground areas by analyzing this kind of measures recorded by the sensors installed there. We, Sistra Subterra, as mining engineers, think that the project will help to the mining of the future, aggregating different technologies from very different fields related for mining or geotechnical engineering. We are going to secure the mining in the upcoming years.
My name is Isis Flokas. I'm a data engineer in Libra AI Technologies, and in Digit, my role is to be the technical manager for the tasks of Libra. I'm here from the start of the project, and we are working on two specific tasks. The one is the decision support system, and the other one is the development of a spatiotemporal person and asset tracking system that will create early warning collisions for trucks and people in the mine. The Digit web-based decision support system brings two game-changing features in the mining industry. Firstly, it supports a fully integrated BI system which users can use in order to get insights about their productivity, monitor air pollutants, and other more things. Secondly, the decision support system features an alerting system in real time that can help people in order to get awareness for various situations around the mining industry, in order to prevent collision between people and assets, in order to get safety regulations compliance, and many more things. The DSS platform is contributing to the project by increasing the sustainability, the efficiency of the mining operations, and giving the ability to the end users in order to follow all the different actions that are taking place in the mine.
My name is Marte Kristine Tøgersen. I'm the R&D manager at Titania, and I'm also the project coordinator for the Titania group in the Digit project. The main focus of Titania in the Digit project has been stability of the open pit, assets monitoring, and environmental monitoring. Titania has a stability challenge in the open pit, and that means that we have a lot of sensors and a lot of data collected from the open pit to make sure that everyone is safe who is in the open pit, and that we make sure that we have access to all the different levels that we need at all times. Our challenge regarding this is that we have a lot of data from different sources that we need to collect together to be able to interpret whether there's a failure going to happen or not. The Digit project will help us with optimization of all this big data by gathering them together and improving our decision support system. The aim of the assets monitoring was to create a better system for predictive maintenance of the mining machines in operation. Titania's challenge related to environmental monitoring concerns water and dust. We have a water discharge from our open pit down to the fjord, which sometimes contains solids and nickel. In the Digit project, we have a sensor that measures turbidity, and we will use it as a proxy to determine whether we'll have nickel in our discharge. Sometimes we have dust going from our tailing pond into a village nearby. We have dust sensors in this village, and we will also, with the help of Sintef Helgeland, a partner in the Digit project, create a website where the villagers can see if it's going to be dust from the tailing pond or not. Another aspect of the Digit project in Titania is Smart Garment. Smart Garment is a useful tool to ensure the workers' safety and health. The most important actions taken by Titania in the Digit project has been providing relevant data to the partners and aiding them in their work in developing the Internet of Things platform. The most time-consuming and fruitful part of the DIGIT project for Titania has been the work with the life cycle analysis. There we have collaborated with SINTEF Helgeland and done a Scope 3 LCA. Scope 3 LCA means that we have taken into account all our direct emissions, energy consumption, water consumption, etc., but also all the emissions from making our mining machines and all our consumables like chemicals and explosive, etc. Everything is in the Scope 3 of the LCA. The technological innovations that our use case brings is the big data optimization, the digital twin for the stability in the open pit, and the digital twin for the environmental monitoring. All of this will improve our decision support system. Since Titania is an end user in the DIGIT project, we have collaborated with almost all the partners, and we have gotten networks throughout Europe in the mining industry. With Itainova and Nemco Norlab, we have collaborated on environmental monitoring. With Subterra and Brunel, we have collaborated with stability in the open pit and the big data optimization. With SINTEF Helgeland, we have collaborated on the LCA and the communication with the community. With Schneider, we have collaborated about the data handling, and with ICCS and IoT, we have collaborated on the smart garment. We have never been part of a project this scale before, and we have learned a lot by collaborating with so many different partners. There are huge benefits for Titania in doing this exercise, because it shows us where to put our efforts in our sustainability work. We are confident that the implementation of the DIGIT project will improve our mining operations in the future. In the DIGIT project, we hope to contribute to a more sustainable and safe mining industry through the cloud-based Internet of Things platform. For Titania, conducting the LCA has been one of the main benefits of the DIGIT project.
Tapojärvi operates and develops sustainable solutions for several process industries, mining industry being the most significant one. Tapojärvi aims to become the world leader in industrial circular economy by 2035. European Union's Horizon Cooperation Programme and DIGIT project are important for Tapojärvi to find and utilize the best expertise in research and development for new sustainable innovative solutions.
My name is Markus Partanen and I work as a maintenance manager at Tapojärvi Company. Tapojärvi Company is a contractor at here Kemi mine, who is owned by Outokumpu. My role in this DIGIT project is to be project manager from our head. And in my background, we can see a Sandvik 517 underground loader, which is a part of this DIGIT project. There have been done some installations on these machines, and we are getting information to DIGIT project from machine itself, from CAN bus, and that information data is shared with 5G network to DIGIT server. Tau is developing that data, and we are getting a lot of information how machine is working, and maybe something about important information that we can predict if some failures may be for predictive maintenance. Then there is also external devices installed which are measuring CO2 levels, and with those data, of course, drivers are getting information about cabin air quality, but also we are getting that data to server, and we can see what kind of environment and air quality is at cabin where our employee is working. All the data what we are collecting, we are transferring in Digit project into the database, and other parties in this project are developing and researching those data.
In a modern and sustainable world, we have to keep workers safe. So we have developed a smart garment in order to make wearables for a safe environment. The smart garment consists of the bracelet in the hand of the worker, the earplug in the head of the worker with speaker and microphone, and of course the main garment, which is a box that is with worker and concentrates all the measurements in order to send them to the Digit project platform. We are very proud of developing a device that is connected to an IoT platform, but at the same time applies edge computing approaches. We're very proud because this device will be a first and initial stage to make commercial use of safety device in the workplaces.
I'm Jarkko Raappana from Tapojärvi, and we have been using these smart garment sensors here in Finland from April. And we wanted to take part in this project because we really think it has a future application in safety, especially here in underground mines. The data we have been gathering, it has been distributed to our other partners here in Europe and other countries as well. We've had a couple of workers using these sensors, and the data we've had from them have been good, and the usability is great.
My name is Jaana Koivumaa and I am manager in Hannukainen Mining. We have been involved in this Digit project when we started to think about the borders here in this area. And I was the one of those group which was planning what to do. Tapojärvi was involved in Digit's project already in the beginning, and they asked us if we have any needs. We need to have a lot of information about local rivers, water quality, before we start mining. In this project, we installed 5 online stations to 4 different rivers. Each station has 5 different sensors measuring water level, pH, temperature, conductance, and turbidity. So Digit will give this all information for us.
My name is Tuomas Lahti. I'm the environmental engineer in Hannukainen Mining. In this Digit project, the goal for us was to improve the data and the usability and reliability of the data we collect from the measurement stations in Hannukainen. Because the data quality we collect in the winter is unsure, in this project we, with the help of SINTEF, our aim was to improve the quality and usability of that data. And also one of the main goals was to get the data to public so we can share it with the people. Lots of mines are located in the cold climate, and the online monitoring has become more and more important in environmental issues. And in Hannukainen we can provide the online measurement data and the station for this project to improve the quality of the monitoring, especially in winter conditions where the temperature can go below -30 degrees and there can be lots of snow and the rivers get frozen. This is one of the stations that we use to collect the data in the waters and rivers here in Hannukainen,
and this one is installed in Valkeajoki. And there is sensors at the bottom of the river that we measure, for example, temperature and pH. And we collect this data to cloud, where the SynDev uses this data in this Digit project to, for example, creating a graphs for us in our website. We hope that in the future, with the results from the project, we can improve the monitoring results and the data from our stations, especially in the winter. And hopefully we can also improve the environmental monitoring and the tools for the monitoring in the mining industry in general.
I am Giulio Marini, owner and CEO of Marini Marmi company. Our main goal in the project is to improve safety in our sector and reduce waste of the material. In particular, with regards to the detection of cracks inside the quarry and foresee if in the future there could be the necessity to have forced ventilation. These two problems are meant to be solved thanks to geotechnical digital twin carried out by Subterra and thanks to the digital twin of the fluid dynamics carried out by Itainova.
My name is Karina, and I'm working at the Nemco Nordlab situated in Norway, where I am a manager of the Department of Environmental Monitoring. My role in this project has been to make these sensor bundles for air monitoring. I've been working with the Marini and the KMA use case and with developing the air quality sensors. It has been very important for us to develop the sensor bundles in such a way that it's cheap to produce and they can deliver data of the good enough quality. They are delivering a data stream to the project so that they can use that for the further process.
I am Matteo Moioli, member of Marini Marmi team. Several actions have been carried out on our use case. Itainova will generate a ventilation digital twin based on our quarry, which will predict real-time properties for inside the quarry, based on outer conditions gathered from a weather station that have been installed. This digital twin is being built by using data coming from multiple CFD simulations that are being validated using data from some anemometers and internal sensors in the quarry. ICCS has designed some smart garments with several functions, such as sensing, for example, skin temperature, air quality, localization, and communication, for example, the headphones. With core innovation, we have been involved in the task regarding predictive maintenance agents and predictive operation system. For the predictive maintenance, core innovation has installed some sensors on the quasar, while for the predictive operation system, we are retrieving data from the machinery. The architecture is based on Schneider Electric software EcoStruxure Machine SCADA Expert. This software collects data from the field via different protocols.
So, core solution that was deployed in the mine of Marini Quarry, is an all-in-one predictive maintenance platform. It's a solution that has an edge device with sensor capabilities and deep learning algorithms that help predict anomalies in the operation of the machine. In the case of the Marini, it was installed in the gangso machine, a machine that cuts marble blocks, and it's a key machine of the quarry in Marini. The user interface that is used in the solution was also given to the Marini operators, and they were able to follow the critical warnings that were shown displayed in the user interface. So in the last month of the project, there have been some critical warnings in the machine that were shown in the user interface, and these warnings predicted actually a fault in one of the assets of the machine. The marine operators were notified early on, and they were able to halt the machine operation and prevent further damage to the machine. This really helped Marini reduce downtime and save money from potential further damage of the Gangshu machine.
During this project, we have met a lot of interesting partners, and we have learned more about the technology we are using. So for us, this has been a really, really nice path to walk along with the partners in the project.
Now that the project has ended, I'm happy to say that I have the confidence that the DIGIT project has been useful to enhance the awareness of the mining industry about the importance of digitalization on their daily activities.